Hello viewers, welcome to my channel. I'm Hasham. Last video I have explained you two problems on chi-square test. In this video, two more problems, third and fourth problem, I'm going to explain. So before that, I have uploaded one video on theory of chi-square test. So if you want the perfect knowledge, perfect command on this topic, I suggest you first watch the theory video, be perfect regarding the meaning of chi-square, when we will apply, why we will apply, what is the formula of calculating chi-square test, how we have to conduct the test. All these things I have explained in the first theory video. So if you have not watched, I suggest you go to the playlist of my channel, select the subject statistics for management, select the video of chi-square test theory, be perfect, then you start the problem. Actually, this chi-square test is a non-parametric test in which we compare the observed frequencies and expected frequency and give the conclusion whether there is difference between observed frequency and expected frequency. So two types of problems are there. First one is association of attribute. Second one is test of goodness of fit. Association of attribute means two attributes will be given whether there is association or not. One attribute will take it in rows, the other attribute will take it in columns, and we'll conclude. So before starting the third problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain the problem. Come on, see the problem number 3. A certain drug was administered to 500 people out of a total of 800 included in the sample to test its efficiency. So here drug manufacturer has produced one drug. Now it wants to find out the efficiency of this drug by treating the patients. So out of 800 people of the sample, 500 are administered the drug, and the remaining 300 not administered the drug. And the results, the actual results are given below, given in the table. So drug, two rows are there, drug and no drug. And two columns are there, typhoid and no typhoid. That means we want to tell whether the drug is effective in preventing the typhoid or not. So out of the 500 people administered the drug, 200 got the typhoid. That means the drug is not effective. And 300 people, no typhoid. That means drug is effective. So in other words, out of 500 people, 300 drug is effective, 200 not effective. Whereas no drug. How many people? 300 people are having typhoid and we have given no drug. So without giving drug, typhoid 280 people and 20 people no typhoid. The total of the typhoid people 480 and no typhoid 320 out of the total of 800. This frequency table, 2 by 2 contingency table, is the observed frequencies. And on the basis of the above data, can it be concluded that the drug is effective in preventing typhoid? Ultimately, our testing is to find out whether drug is effective in preventing typhoid or not. So we will start our answer like this. First of all, observed frequencies, whatever given in the problem. Same table I have drawn here. The drug 200, 300, 500, 280, 20, 300, 200 plus 280, 480, 300 plus 20, 320. Total is 800. This is called observed frequency table. Now we make the expected frequency table. Here there is a mistake here. Instead of observed, it is expected frequency table. It is not given in the problem. We have to find out the expected frequencies. How to find out? First of all, from the totals of the column and row, same total you copy down. This is 480, 480, 320, 800, 500, 300. Now, the expected frequency formula is row total into column total divided by grand total. This thing I have explained in the theory video also. So while watching the video, I suggest you always keep a notebook, pen, calculator ready. When I explain something, immediately write it down. So what is expected frequency? Row total into column total divided by grand total. Grand total is 800. So what is the row total here? 500. What is the column total? 480. So 500 into 480 divided by 800, you will get 300. This 300 is the expected frequency. Similarly, I need the expected frequency for this cell. So row total 500, column total 320. So row total is 500, column total is 320. So 500 into 320 divided by 800, you will get 200. Similarly, here row total is 300, column total is 480. So 300 into 480 divided by 800, you will get 180. Right? Similarly, row total 300, column total 320. 300 into 320 divided by 800, you will get 120. Now you can confirm the totals. 300 plus 180, 480, 200 plus 120, 320, 300 plus 200, 500, and 180 plus 120, 300. This is called expected frequency table. Now we compute the value of chi-square. The formula of chi-square is summation O minus E whole square by E. So first of all, O. O stands for observed frequencies. So row wise you take 200, 300, 280, 20. So 200, 300, 280, 20. Similarly for expected frequency 300, 200. So here 300, 200. 180, 120, 180, 120. So I have copied down the observed frequencies and expected frequency. Next column O minus E. Observed minus expected. So 200 minus 300 minus 100. 300 minus 200 plus 100. 280 minus 180, 100. 20 minus 120 minus 100. Now square this O minus E whole square. 100 into 100. Minus into minus will become plus. So 100 into 100, 10,000. Similarly 100 into 100, 10,000. 100 into 100, 10,000. Minus into minus will become plus. 100 into 100, 10,000. We got O minus E whole square. Now O minus E whole square divided by E. So O minus E whole square divided by 10,000 divided by 300, 33.33. 10,000 divided by 200, 50.00. 10,000 divided by 180, 55.55. 10,000 divided by 120, 83.33. Now take the total of all these four values, you will get 222.21. This is the summation O minus E whole square. This is called the computed value of chi-square. Now step 1. Totally 6 steps are there for testing chi-square. First is null hypothesis. That means the drug is not at all effective in preventing the typhoid. Drug is not effective in preventing typhoid. No association at all. No difference between observed and expected frequency. Always you have to keep in mind how to frame the null hypothesis. No difference between expected and observed. The drug is not effective in preventing the typhoid. Alternative, yes, the drug is effective in preventing the typhoid. Opposite of null hypothesis, alternative. Now next is level of significance. Level of significance means at what percentage level of risk you are giving your opinion, your decision. So normally it will be 1%, 2%. If nothing is specified, we assume 5%, 0.05, assume. Then degree of freedom. Degree of freedom, V is equal to C minus 1 into R minus 1. C stands for row, C stands for column, R stands for rows. So here 2 rows and 2 columns. So in place of C, 2, in place of R, 2. V is equal to 1. Test statistic, the computed value of chi-square is 222.21. Already we have calculated here. Now critical value. Now you have to refer the table value of chi-square. This table value of chi-square you can find in any textbook, and also in description I have given a PDF also. So at 5% level, at 5% level means column 0.05. 1 degree of freedom. For 1 degree of freedom, 0.05, 3.841. 3.841. Now decision. The computed value of chi-square 222.21 is very much greater than the critical value 3.84. So this value falls in rejection region. We reject the null hypothesis. When it falls in rejection region, when the computed value is greater than critical value, the value falls in rejection region, null hypothesis rejected. This hypothesis, drug is not effective, is rejected. Then this hypothesis will be accepted. What is this? Drug is effective in preventing typhoid. The ultimate conclusion, the drug is effective in preventing typhoid because the computed value is greater than the critical value. That's all. This is the end of problem number 3. Come on, now we'll start the fourth problem. 2000 digits are chosen at random from a set of tables. The frequency of the digits are as follows. Suppose a table contains 2000 digits and we are counting how many times 0 occurred, how many times 1 occurred, how many times 2 occurred. So we have counted. So in those 2000 digits, 0 occurred 180 times, whereas 1 occurred 190 times, 2 occurred 230 times, 3 happens 210 times. Like that we have counted 0, 1, 2, 3, 4 up to 9. 9 has occurred 150 times. So you can see every digit is occurring different number of times. That means highest is 250. See, number 5 has occurred 250 times. Whereas the lowest is 150. Digit 9 has occurred 150 times. That means different digits are occurring different times. So different digits occurred different number of times. Now use the chi-square test to assess the correctness of the hypothesis that the digits were distributed in equal numbers in the tables from which they are chosen. So we want to find out whether digits are equally distributed or unevenly distributed. Our null hypothesis, yes, the digits are equally distributed. Alternative hypothesis, no, the digits are not equally distributed. Some digits are occurring more number of times and some digits are occurring less number of times. That is our alternative hypothesis. But first of all, we'll calculate the expected frequency. The number of digits from 0 to 9 is 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 10 digits are there, including 0. So 2000 digits are there. And if equal number of times every digit must occur, then 2000 divided by 10. That means every digit must occur 200 times. 0 should occur 200 times, 1 should occur 200 times, 2 should occur 200 times, like that. That is the expected frequency if the digits are equally distributed. So our answer, let us take the hypothesis that the digits are equally distributed in number. On the basis of this hypothesis, expected frequency of each digit will be 2000 divided by 10. So 200 is the expected frequency for every digit. Now here, observed frequencies. Observed frequencies are given in the problem. 0 occurred 180 times and 1 occurred 190 times. So 180, 190, 230, all these are the observed frequencies I have copied from the problem. Then expected frequency, just now we have calculated 200. For every digit 200. Now these are the expected frequency. O minus E, 180 minus 200 minus 20, 190 minus 200 minus 10, 230 minus 200, 30. So I have taken O minus E. Now square it. O minus E whole square, 20 square, 20 into 20, 400. Minus into minus will become plus. So 10 into 10, 100. 30 into 30, 900. Like this square. Now square, after squaring, divided by expected frequency. O minus E whole square divided by E. So 400 divided by 200 is 2. 100 divided by 200 is 0.5. 900 divided by 200, you will get 4.5. So O minus E whole square divided by E. The total is 43. This is the computed value of chi-square. This computed value we have to compare with the critical value. Then we can take the decision. So now hypothesis, the digits are equally distributed. All the digits are equally distributed in the table. That means there is no difference. There is no significant difference between observed frequency and expected frequency. An alternative hypothesis, no, the digits are not equally distributed. Some digits are occurring more, some digits are occurring less. Now, there is significant difference between observed and expected. Level of significance, it is not given. Sometimes it will be given in the problem, sometimes it will not be given. Here it is not given. So we have assumed 0.5. That is the assumption for 5% level of significance. Degree of freedom. In this case, the degree of freedom was C minus 1 into R minus 1. When the problem is of association of attribute, the degree of freedom is C minus 1 into R minus 1. This degree of freedom formula will apply when we are having association of attribute problem. But this is not association of attribute problem. This is called test of goodness of fit, where a set of frequencies are given observed, a set of frequencies are given expected. There is no contingency table. There is no table consisting of rows and columns. So here the degree of freedom is V is equal to N minus 1. V is equal to N minus 1. N stands for number of items. Here 10 items are there. 10 items are there. So 10 minus 1, 9. So V is equal to 9. Now test statistic, computed value of chi-square is 43. Now critical value. For critical value, we have to refer the table. For 9 degree of freedom, so row wise you see 9 and column wise you see 0.05. So what you will get? 16.919. This is a table value, critical value, whereas computed value is 43. So now you have to take the decision whether computer value is less than or greater than the critical value. If the computed value is greater than the critical value, the null hypothesis is rejected. Write it down. Whenever computed value is more than the critical value, the null hypothesis is rejected. Here null hypothesis. The digits are equally distributed. That we will reject. Then what we accept? The digits are not equally distributed. So finally, the conclusion is the digits are not equally distributed in the table. And in decision, you should write down the computed value of chi-square 43 is greater than the critical value in 16.919. So it falls in rejection region. Null hypothesis is rejected. Alternative hypothesis is accepted. And alternative hypothesis, the digits are not equally distributed. That's all. So two problems I have explained in detail, that is third and fourth. Inshallah, we'll continue the next problem in the next video. If you are satisfied, give a like to the video, share my channel among your friends, among your groups, so that more students can watch the video and enhance the knowledge. And subscribe my channel if you have not yet subscribed. Inshallah, we'll continue the next problem in the next video.